Welcome everyone. In this video lecture, we will solve a problem of microelectronic circuit. So the question is, find the drain current and voltage of Q2 transistor. So this one is our NMOS, Q2 transistor is there, and this one is Q1, and this one is R resistance, and VDD 3 volt and R2 20 um, kilo ohm. So this type of question we have already covered in the previous video. So we will take the help of that one. So this one is our Q1 transistor. So Q1 transistor is here where this gate one, the gate of this and drain of this is sorted, and this one is the source one or source of this transistor. So when the gate and drain sorted, it is in the saturation region. Okay, we have already discussed, so you can also follow the earlier video. So after that, we have to find the value of VGS. So here the current is given in this question. So ID is given 80 microampere. That is our ID1 we can say. So this one is the saturation region. So one can directly write the drain current equation. Okay, mu1 Cux by 2 W by L. First I am solving that earlier one, then we can easily solve this one. Then VGS minus VT whole square. So now this one is given. So after solving all these things, W by L everything we have solved. So we will get the value of VGS1 is 1 volt. Okay. So now this one source one is 0. So VG1 is 1 volt. So we can also show the VD1 is 1 volt here. VD1 is 1 volt and this current is 80 microampere. So it is already given. So this part we have already discussed. So I'm just taking this as a help. So one can say simply this current is nothing but simply our 80 microampere, and this one, this gate to source voltage VGS1, that is our, this one is our gate 1, drain 1 and source 1. This is our gate 2, drain 2, S2. Okay, so here this one is our VGS2. So here VGS1 is same as that of VGS2. Okay, get to source voltage will be same, that is our 1 volt. Okay, clear? And this Q1 is in the saturation region. Q1 is in saturation region. Okay, and both the transistor Q1 and Q2 are matched. Okay, having the same values of mu1 Cux everything. So one can easily say this get to drain to source voltage VDS2 will be nearly same. Okay, but there will be change due to this resistance and this one is connected. So now this Q1 and Q2 are meshed. So Q2 transistor is also in the saturation region. So the almost same current will flow from this one, that is our 80 microampere, and this was a very famous example of current mirror. Okay, the same current will be replicated here 80 microampere to 80 microampere when this kind of structure will be there. So this one is 80 microampere. So we have to find the value of voltage at Q2. This is our VD2. We have to find VD2. So what we can do, one can simply make the this part is okay 80 microampere. This is the way how to find. You can also go for my earlier video. So now this one is the resistor, this one is the transistor. Okay, and this one is 3 volt, and this one is current is 80 microampere, and this R2 is 20 kilo ohm. Okay, and this value will be plus or minus VDS2 one can write. Okay, so if we apply KVL in this loop, we can write 3 volt, that is our VDD, or simply we can write like first write VDD minus R2 ID2. This one is simply our ID2 current. So better to write minus R2 ID2 minus VDS2. This one. Okay, some voltage equation. Then we can write VDS2 equals to VDD minus R2 ID2. So VDD is 3 volts, so make it 3. R2 is 20, so 20 kilo ohm, and ID2 is 80 microampere. Okay, so one can write 3 minus 1600 into 10 to power minus 3. So if we solve, it will come 3 minus 1.6, it should be 1.4 volt. So now VD S2 will be 1.4 1.4 volt. So S2 means VD minus VS2 is 1.4. So this value will be 0 because this source is grounded. So simply we can say VD2, better to write 2, is 1.4 volt. So in that way we can solve this question. Is voltage across this in will be 4 point, sorry, 1.4 volt, 1.4 volt, but here this voltage will be 1 volt. Okay, this VD1 is around 1 volt, but VD2 is how much? 1.4 volt. We have to write 1.4 volt. Okay, so this is all about this question. So thank you for watching this video. So in that way we can find the current and voltage across the Q2 transistor. So thank you for watching this video.